Today's lesson is on three-dimensional figures. We talked about area in the last lesson, which was two-dimensional. You could fit it on a piece of paper, a flat surface. Three-dimensional figures cannot be fit onto a flat surface. We can draw them to kind of represent a figure, but the actual item itself would not fit on a piece of paper. Okay? We call some three-dimensional objects polyhedrons. A polyhedron has flat surfaces, and those flat surfaces are polygons, like we just spoke of in the last section. We call the flat surface a face. So it's a plane, it's partial plane, because it has boundaries. It doesn't go on forever. Where these two faces, or three or four faces, meet along an edge, along a straight line, is called an edge. So it looks like a line in the drawing. And then where all the edges come together makes a point, and we call that a vertex, similar to the vertex of an angle. So if we have, this is called a rectangular prism because it's made of rectangles. Okay, so this would be a face. These flat surfaces are faces, as these arrows indicate. Where the top face and the back face come together, form an edge, which is a straight line. And then where these two edges, actually three edges along the back and the side come together to a point is called a vertex. Know the difference between a face, an edge, and a vertex. How to count how many there are in a certain figure or object, and how to name them. Okay, specific types of three-dimensional objects. We have prisms and we have pyramids. What is the difference? Prisms have two congruent parallel bases. Two congruent parallel bases. Pyramids have one face at the bottom, and then all the other faces come to the same vertex. So let's look at some examples here. Here we have a prism, triangular prism. Notice that the two ends are triangular shaped. They are parallel to each other. They would never touch. They are congruent. They have the same size. It's kind of hard to tell in the picture because one looks smaller than the other. So this is a prism. It has two bases. And the bases are always the two parts that are the same shape. Here's another prism. This is called a rectangular prism because these ends that are the same exact shape, that are parallel to each other, are rectangles. Here we have a pentagonal prism because, again, the two ends that are parallel to each other, where there's only two of them the same shape, are pentagons. The other shapes are the same, but there's 5 of them, so those would not be called the bases. The bases are the two shapes that are the same. There's only 2 of them. Here in our last picture, we have a pyramid. The difference is there's only one base. The pyramid tends to sit on its base, whereas the prism can, or maybe not. Okay, so here the pyramid has one base, and all the other sides come up to this common vertex, as our definition says. All but one face come to the same vertex. So they come up to a point. Okay, so let's go through some pictures and see if you can determine if they are a pyramid or a prism. Okay, is this a pyramid or a prism? It is a prism. It is a prism because it has two bases. This time it's sitting on the base. They're parallel, and those are the only two sides that are this shape. What shape is this? This is how we name the prism. How many sides does it have? 1, 2, 3, 4, 5. What is our polygon that has 5 sides? It is the pentagon. So we would call this a pentagonal prism. Okay, is this a prism or a pyramid? You should have said pyramid. Why? It has only one base, and all the other sides come up to a common vertex. Now, to name this, we have to look at the shape of the base. It's unclear whether this is a square or a rectangle. We're going to assume all sides are the same. I know we're not supposed to assume, but it was named a square pyramid, so that tells us that all sides are the same. Pyramid or prism? And how would you name it? Okay, ask yourself, how many bases are there? There's 2. And what's the shape of that base? Well, there's 6 sides, so it's a hexagon. So you should have called this a hexagonal prism. Prism or pyramid, how many bases does it have? What is the shape of that base? We have 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is an octagon. It's going to be an octagonal prism or an octagonal pyramid. If all the sides come up to a point, then it is a pyramid. Octagonal pyramid. Pyramid or prism? Should say pyramid, and hopefully you named it a triangular pyramid, the shape of the base. Pyramid or prism? And then name it. What did you get? Rectangular prism. Okay, this is not a polyhedron because it does not have flat surfaces, but you still need to know how to name it. We don't call it a ball in geometry. Looks like a ball, but the geometric name is sphere. Here's another three-dimensional object that doesn't have all flat surfaces. It has curved surface. It has 2 flat bases that are both circles, and they are parallel to each other. So it's kind of similar to a prism, except that this area is curved. So it's not a prism, it is a cylinder. And our third non-polyhedron, again, we do have one flat surface, the base, which is a circle, but the rest of it is curved or round. It's not a cylinder because there's only one base. What would we call it? In the summer, you like to eat snow and ice cream cones. So it is a cone. Okay, let's go through some more. What do you call this? Triangular prism. Okay, so we have some non-polyhedron solids that we just learned. You need to know how they differ from polyhedrons. They have faces that are not polygons. They were circles, remember? So they didn't have straight edges. Or they have no faces at all, like the sphere. So the three that you need to know are cylinder, cone, and sphere. They're rounded. A cylinder has 2 circles as the bases. A cone has 1 circle as the base, and a sphere has no bases. Okay, we're just going to talk about surface area and get a general idea of what it is. We're not going to do a whole lot of calculations at this point. We'll do that later on in chapters 12 and 13. But I want you to know what surface area is. And it's basically the area of the surface of an object, what you can touch, all the different faces added together. So find the area of each face, add it up, and that gives you the surface area. If you cut along some of the bases of a three-dimensional object and lay it flat out, you get what's called a net. A net is a pattern that you can cut and fold to make a model of a solid shape. For example, if I were to cut this cross out along the perimeter here, I could fold it up and tape the edges and I would get a cube. So this cross is one of the possible nets for a cube. If I found the area of section 1, section 2, section 3, section 4, 5, and 6, and added those all together, I would have the surface area of this cube. The area of the surface. If I calculated how much space that cube took up, that would be volume. Or you could also think of it as how much material it would hold, how much air is inside. That is volume. So we have area, which is just a flat surface on a two-dimensional shape. Surface area is all the areas added up for a three-dimensional object. And then volume, which is how much material a three-dimensional object can hold or how much space it's taking up. Know the difference in those three terms: area, surface area, and volume. Here's a chart that gives you the formulas for surface area and volume. You just need to know how to use them. You don't have to have them memorized. Anytime you see a capital letter, that means the area of that part. So big P is going to be the perimeter of the base, the whole, all the way around the base. Big B is the area of that base. Okay, the area in this example of this square in this prism. H stands for height. R stands for radius. L stands for slant height. So over here on our cone, this is the slanted height. The one that goes straight up and down is H height, straight up and down height, perpendicular height. But when we slant it and go from the base to the top, that is called the slant height. Okay, so again, we're going to be mostly concerned about these volume formulas for now. Just know that there are surface area formulas. And all you do is plug in the parts and do the math. So let's do a couple of examples here. Okay, we have a square prism. Now we need to have some numbers in here. If I can get my pen to work. We need length, width, and height for that cube. Well, here we go. Ugh. Okay, so let's say that we have a side here of 6, and we'll do 2, and then we'll do the width or depth. We'll do 2. We'll say it's a square pyramid. So the area is going to be the area of the base times the length. Okay, well, the area of the base, remember, the bases are the two ends that have the same shape. There's only 2 of them. So this is one base, and the other one is down here where we can't see it, but we know they're the same shape. What shape are they? They are squares. What's the area of the square? Okay, so we got to come over here. Our big B is the area of a square, which is the side squared. 2 squared. What does it mean to square something? Multiply it times itself. So 2 times 2 is 4. So my area of my base is 4. Now I need to know my length. Well, the length is always the longest part. So that's 6. I'm going to multiply those 2 together. And I get 24. Box in your answer. So this will be given to you. You just need to know what those letters mean. Again, a capital B is the area of your base. So you had to find area. And this should actually be volume, not area. Should be volume. My bad. Okay. Let's erase all that. Let's do another one. Okay, is this a prism or a pyramid? It is a pyramid. The volume of a pyramid is 1/3 the area of the base times the height. So again, we need some numbers in here. This looks more like a rectangle to me, so let's call this 2 and this 3. And then we need a height in here. It has to be given to you. I know I didn't draw that very straight, but we're going to say that that's a right angle. And we'll say that it's 5. Oh my goodness. This pen is not wanting to cooperate. There we go. All right, so again, we need to find the area of my base. So I kind of do that out as a separate equation. Okay, the area of my base is this is a rectangle, so it's going to be length times width. So I do 3 times 2, which is 6. So then I come over here and I substitute that 6 in place of my big B. Again, I'm working in a very methodical way, starting off with my formula and plugging in numbers as I know them to replace the letters. What is the height of this? We said it was 5. Now I'll do the math. Again, sometimes it's easier to just go on and take 1/3 of one of these numbers if it goes in evenly. 3 does go into 6 evenly 2 times. So I end up with 2 times 5. So my volume ends up being 10.